In this video, we'll be looking at how we actually construct these reference electrodes. Of course, we don't want to have to make a beaker every single time, put KCl in it, right, do all those things. So instead, manufacturers have made these into a much smaller package that we can use much more simply. And so the figure on the left is a figure from your textbook. This is a silver chloride reference electrode sort of compacted into a small thing that you can just buy and put into a solution directly. So we have up here, your wire lead that you're going to use to connect to your potentiometer. You'll need to connect the other side to, whatever other electrode you're going to use. There is a air inlet here to allow a little bit of electrolyte to drain slowly through this porous plug down at the bottom. And so then this wire lead, this is our silver solid right here. And then there's a silver chloride paste that's present here as well. And then we have our KCl down here, because of course we need this to be a saturated KCl solution. And to be able to connect this electrically to another solution, we need a salt bridge. And so down here we have a porous plug that acts as our salt bridge that allows migration of ions between the internal solution inside of the electrode and the external solution that you're doing your measurement in. And so this has everything that we need for our measurements, but now it's all in one package that we can just stick directly into a solution. Many times this is even packaged inside of another electrode. The chloride electrode that we used in lab works this way. It has a reference electrode built inside of it that looks something like this, and then the actual indicator electrode, or the sensing electrode, we'll talk about indicator electrodes in just a little bit, is on the outside and does the actual measurement. On the right, we have another example of how you can construct this. This inner electrode here is essentially the same as this right here. But maybe you have something where you want to make sure chloride doesn't get into your solution that you're measuring. Maybe it precipitates with something that's present or whatever. And so you have a separate outer compartment here that can be filled with some solution that's compatible with your solution that you're measuring. And so we have two separate porous plugs here that allows, overall, we have a electrical connection throughout this entire thing. And so we have this, this is what's called a double junction reference electrode. But same idea here, right? The overall idea, again, remember, is that we have a stable voltage that we're going to compare things to. So the silver chloride reference electrode is probably the most common reference electrode. Another common reference electrode that we can make, as we come down here, is what's known as the saturated Calmal electrode. So this uses a different electrochemical reaction based on mercury chloride, which is this Calmal. This is mercury chloride. All right, and so this is going to have a slightly different potential because it's based on a different reaction. And so the reaction involved here is we have calomel, our mercury chloride here. That's a solid. Will react with an electron. All right, so this is the reduction reaction here, and will be reduced to liquid mercury and chloride. And so again, because we have a pure liquid and a pure solid present, those don't show up in our Nernst equation. We just need to fix the concentration of chloride, and we use the same idea as the silver chloride electrode, is that we have a saturated KCl solution to fix the chloride concentration, right? So that we have a known concentration of chloride. All right, and so so E naught for this reaction, if we look it up in the table, is positive 0.268 volts. But for the saturated electrode, if we have saturated chloride, saturated KCl solution filling our electrode, we get a potential of 0.241 volts. All right, and so that is, right, this is the known value that we would use in doing an actual measurement. And so in the picture here, we have, again, very similar. We have our salt bridge down here. We have solid KCl down here, so that we have our saturated KCl solution. We have liquid mercury inside of here, as well as mercury, calmal, mercury chloride. And then this is all connected with a platinum wire, because of course we don't have a solid metal, we have a liquid metal. We don't have a solid metal as part of this, and so we need a different sort of metal to be able to connect in. So this is another type of reference electrode that we can use, has a slightly different voltage. But same idea, same basic idea as the silver-silver chloride electrode. So in the next video, we'll look at how we can start making measurements of unknown species, right? So we have a reference to compare it to. Now we need to look at the first example of how we can measure concentrations.